Okay, an electron traveling at a speed v enters a magnetic field of strength B. So I've drawn this picture here, or used this picture, and my magnetic field strength we're imagining is into the page. So these little X's represent my magnetic field, nice and uniform. And when you have a charged object moving perpendicularly in a uniform magnetic field, the object will undergo circular motion. So we've done that in the previous video example. So here we have an electron. So all the forces are going to be opposite if you use your right-hand rule. So if I put my thumb along this direction at the bottom where location B is, and my fingertips into the page, the palm of your hand will push down, but because it's an electron, my force will always be up towards the center of the circle. So it's due to the magnetic force. So if you prefer, and this is how I do it, it's an electron, so I'm just using my left hand. So if I use the same rule but using my left hand, my thumb is up. Let's look at region A. My thumb is up, my fingertips are into the page, and I get a force that's towards the center of the circle. Now, because it's circular motion, all we're going to do is dynamics. Doesn't matter where I'm at, the only force that's acting on it is my magnetic force. So my net force, which is MA, is going to equal the magnetic force acting on a single moving charge, which is QVB. And again, the only criteria for this equation to work is that V and B have to be 90 degrees to each other, which they are. Now, because you're moving in a circle, we're going to go AC. And when we look at the question, where they give you the electron speed, and what they're going to do is double the field strength and double the speed. So the version of the centripetal acceleration we'll want to use is the one with speed in it. So I'm going to go mv squared over r is qvb. Now we can do a little canceling. This velocity and this velocity cancel each other off. The question's asking, what about the radius, right? What happens to the radius when I do those two things? So let's solve this equation for r. So multiply both sides by r to get it on top, and then divide by qb. And I end up getting r is mv all over qb. Now, we're changing the strength of the magnetic field, so we're changing b, and we're changing the speed. We're leaving the mass and the charge of the electron constant. So really what's important is the relationship between the radius and velocity and magnetic field. And if you look at the equation, r is directly related to the velocity. So if I double the velocity, I double the radius. And inversely related to b. So if I double b, I half the radius. So you can see what happens. I just put the numbers in. If I double the velocity and double the magnetic field, the net effect is canceled and the radius will be the same. R2 will equal R1. Same value.